Hello, this is the functions C3. This is the second topic in the C3, whatever you want to call it. And what is a function? Okay, so we're going to start by the simple definition. A function is something like 2x plus 3. Y equals 2x plus 3, which you might go, that's an equation of a straight line. Correct. But it's just meant to be a function. Not necessarily, it could be quadratic or whatever. It's a function. Okay? So say for a y value, to get a y value, do 2 times the x value plus 3. Now, main key thing at the start of functions, they talk about domain and ranges. Okay, so domain and range. What is a domain? What is a range? Okay, so what I'm going to do is I'm going to emulate this by drawing a graph. Actually, I'll do it of this equation. So it's y and x. So your y-intercept is going to be 3. Your x-intercept is going to be, sorry, 3 over 2, so 1.5. Yeah, so negative 3 over 2. Sorry, let's think about that. So your line is going to look something like that. So that's going to be, sorry, it should be straight 2x plus 3. So that's going to be your line, okay? So far, nothing about domain and ranges. Now, I've not drawn it to any limits. This line here could keep going on and on and on. Or it could keep going on and on in the other direction. We've got to limit it. Now, what that is called is the range. Sorry, I should have mentioned domain first, that's why I was a bit and ahhing. So the range is how wide it is, and now what's across the horizontal scale is the x-axis. So basically what we're saying, summary, is the range, the domains, sorry, the domain is the x values. So basically, it's the values you put into the equation above to get the range. So the range, therefore, is the y values. So that's what we mean. So basically, if you think about it, the range is how high. So the range is from y equals 8 to y equals 6, for example. So you could write that as, if you're including 6, it'd be something like this. So the range, if we were between y equals 8 and y equals 6, it'd be 6 including, you just write like an inequality. So that's your range, just an imaginary range. Obviously it's not this range, but basically the domain, the values before you put it into it, and the range is the values you put after you get out of the equation. It's essentially what domain and range is there. If you want me to add anything to that, if you've got any ideas about that, I mean that's as far as I'd go with it, to be honest. But if you want to find out any more, just let me know. Okay, so I'm going to assume that you're okay with that. So a one-to-one function. So the different types of functions. Right, just tried to look for my rubber there, it didn't work. Okay, so what type of function do you think this is? I'm going to tell you the type of functions, assuming you don't know about functions. There's a one-to-one function, a many-to-one, and something that is not a function. So what do you think that is? Now, I've already told you it's a function, so it discounts the last one pretty much immediately there. So what do you think that is? Yes, no, correct, yes, possibly, no. What this actually is a one-to-one function. What we mean by that is for every x value we get a y value. Sorry, for every y value we get an x value. So if I draw my imaginary line across here, I'm not going to say what this is. I have no idea. This is y equals given value. So it's y equals 8, for example. And we hit the line at the x point, corresponding value. So what this is for every y value we've got one x value. So this could keep going on and on this line, but we'd only ever meet that line at that point there. So it's a one-to-one function. Now, there are other types of functions that you could come across. If I can just sack that. I did try to like be quite professional there with my stuff, but never mind. So assuming that's the same kind of thing, what you might be familiar with is your x cubed graphs. Now I'm not just gonna draw not necessarily a standard x cubed, but so that's y equals x cubed. And obviously it'll be like, you know, y equals x cubed plus 2x plus 3 or whatever. But just assume a y cube looks like that. So if we say y equals a given value here, that is, we've got many functions here. We've got 1, 2, so x, sounds like a second text message, x. So we've got 3. For one value here we've got of y, we've got 3 x values, but if we do it a bit higher up, assuming this keeps going, we've only got 1. So what we've got here is we've got a function which says, oh, at this point there's 3. It's a one-to-many function. But at the higher points we've got a one-to-one function. Hence, we can't have different types of functions. It's one or the other. It's either a function or not a function. So that is not a function. So that's what we mean by functions. That's the kind of simplified introduction to it. What we're going to do now. Now this functions topic, it does go on for a little bit. There's what we're going to be doing is composite functions in. Sorry, I'm just trying to. I do know what I'm talking about. I'm just trying to get in the right order. So composite functions, inverse functions. What an inverse function would look like on the graph. Graphing certain functions, inequalities, and then just transformations of the graphs. So we're going to start by. I found my rubber, because that should give me a good pointer. Maybe that was all distraction, just to find a rubber. Okay, so what we've got here is we have, so we've talked about domains and ranges. I'm assuming you're familiar with that. Okay, so what do we mean by composite functions? Now in the previous little bit, I've said y equals this, or y equals a given function. Well, we could have easily fx equals the same given function, 2x plus 3, for example. Or gx equals 6x plus 3. Now these are two different functions. And what I'm going to say now is a bit like polynomials. So, simple stuff really. So, what this x means is we put x into this value. So, f of 1 would be 2 brackets 1, so 2 times 1 plus 3, and then that would get you 2 times 1 is 2 plus 3, that would get you 5. Do the same for here, g equals 1, g1 equals 6 times 1 plus 3, and then 6 plus 3 is 9, so g1 equals 9, f1 equals 5. So how does this relate to functions? Okay, so I said combining functions, composite functions. Now, generally, this is sort of C2, sort of C1 stuff really. What they'll ask you to do at A2 level is say, right, okay, so you've had fun playing around with your standard integer numbers here. What we're going to do is we're going to put a function into another function. So, what does this mean? So, we've got g f of x, and we'll say, find g f of x. Now, what this actually means is, instead of g1, is g f of x. So the function of x, which equals 2x plus 3. So it's actually saying g of f of x is putting the function of x into every x of this other formula. So hopefully, so that there, them two last equations, the g thing, that they are exactly the same, and that is because f of x equals 2x plus 3, and all I've done is they equals the same, so I've just put it in there, and that is going to be, we're going to sub that in for every x that's in the g equation, so you're sort of reading left to right instead of right to left. So that's essentially what we do. Okay, so assuming the old function here, so 6x plus 3, so 6 times what's ever in here, so it's 2x plus 3, just happens to be this function because we've put f of x there, 2x plus 3. And then that would get us 6 times 2, 12x, 6 times 3, 18, plus 3. And then that would get us, so 12, if we simplify that, so we still got 12x plus 3, 21. So that's what we get. Now that is a completely reasonable assumption there. That's generally what they'd ask you. I'm going to step it up a slight notch here, because they might say, well, okay, that's fairly simple. There might be another part of the question. They'll try and make it as complicated as they can, because the exams, they don't set them to be easy, they set them boys away from the men, and the women away from the girls, etc. So, how can we show this? Oh, I shouldn't have rubbed them off. So, I'm assuming these are going to be the same 2x plus 3, fx, shouldn't have rubbed them off, sorry. Gx equals 6x plus 3. So, that's what we had before. Now, instead of putting g of f of x, I'm going to put g squared x. Now, what does that mean? It just means that's squared, that's all it means. So, we're still putting x in here, just 6x plus 3, and we square that. And you could just do that as a double bracket, and we'd go like we normally would. So 6x plus 3, 6x plus 3, and then we'd expand that, so I don't know what that'd come to. So that'd be 36x squared. So if any of these small calculations are wrong, but the method's right, 36x squared plus 3 times 3 is 9, 3 times 6 is 18, we're going to do that twice, so 18 times 2 is 32, 36, sorry. Wait, sorry, my mind's actually gone. 36x. I'm simplifying. Well, yeah, 36. Yeah, that's perfect. So that'd be the answer to that equation there. So equal each other. So hopefully that's kind of self-explanatory. They won't give you. They might put the equation in. They might do that the cubed or whatever, but it'd be the same principle. And then the first principle, g of f of x, you might do g f of x of k of x, and you just work from right to left. But that's the main idea of it. I don't want to make you too confused on that section, but hopefully that's covered the basics. So again, just let me know if you want me to repeat anything or explain anything with some more questions. Now, I do have some exercises that go along with this, which I'm going to get through the material first, and then add an additional part where we do past paper questions and general hints and tips about it. Okay, so what's the next part? So we've done composite functions, so essentially all we did there was we put a function into another function. So the next thing that we can do is inverse functions. So, you may recognise this. Now, that is not an inverse function. Sorry. Now that is an inverse function, sorry. This, so that is an inverse function. So f to the minus 1 of x, that's an inverse function. However, f dash x, that is not an inverse function, that is the derivative, so dy dx. It's imperative you make the difference. So I'll just step back, because this is the point where someone will ask, that looks like a derivative, and hopefully you can see the difference there. So f to the minus 1 of x is the inverse function, f dash x is the derivative, and f double dash x is the second derivative, etc. You would have learnt from C2. That's why people get confused. It's easy to get confused, but you need to be able to make the difference in the exam. They don't mean the same thing, even though they look quite similar, I think you'll agree. Okay, so that's the main, sort of my key point out of the way there. Right, so just going to leave that on the board. I'll draw a little dotted line underneath it, so you can keep yourself thinking about the questions that'll come up. Okay, so what is an inverse function? So f(x), it's very good, we know what a derivative is, that's just the derivative. So say we've got given f of x, and f of x is 2x plus 3. What this essentially is the same as saying y equals 2x plus 3. These are the same thing, not changed anything at all. Just put y instead of an fx, which mean the same thing. Now the inverse, so if we want to do the f to the minus 1, not dashed, so f to the minus 1 of x, what we're saying is we want to rearrange this equation, well, shouldn't put equals, well, arrow. What they're essentially saying is rearrange the equation, make x the subject of the equation. So what we do is y take 3 equals 2x, and I'm going to break it down in steps, not going straight to the 1. So that'd be y take 3 over 2 equals x, and that'd be the, so the inverse of 2x plus 3 is y take 3 over 2. So instead of saying x, that's, you can say that's f to the minus 1 of x. So that's the inverse function. Now what I'm going to draw now is I'm going to emulate this graphically. So leaving it on the board. So what happens when we do the inverse of a function? Because we said y equals 2x plus 3, that is a graph. And if we inverse it, what happens to that graph? Now I don't need to do an x and y table for this, but for the benefit of the doubt, I'll try and see if we can fit it in. So draw our standard graph. So x and y there. Now we should all know what 2x plus 3 is because we've drawn it before. Has an intercept of 3 and a y-intercept of 3, sorry, and 3 over 2 as a x-intercept, or something like that. That's y equals 2x plus 3. I'm going to draw this other line in a dotted form. And I'll explain why I can just do this so easily right now. That's 3, and that is 3 over 2 negative. So how do we know that's the right one? Well, it's reflected in the line y equals x. That's why that 3 is there, and that minus that 3 over 2 is there. So we could just prove this, so y equals, y over 3 equals, y take 3 over 2 equals x. So that's the equation of this dotted line here. So hopefully you're following this. So essentially what we've done is we've mirrored that line in that line to create this, and the mirrored line is y equals x, but the line that we've drawn that's been reflected is y take 3 over 2 equals x. Now we could work out the x-intercepts, so if we did the x-intercepts we should get 3 for the second one, so x, yeah, that should be correct. So it's basically reflected in the y equals x line. So you can double check that by just doing your x's and y's. If that's wrong, just let me know. It shouldn't be, and they should be all correct. So teach keeping you on your toes here. Hopefully you understand that, and that's that part of the course tick done. So hopefully you've got that. Now, the reason I'm trying to go a little bit fast, I don't want to waste too much of your time, as I'm quite aware you have a life. That's why you're watching my videos. Okay, so what we've done so far is we talked about domain ranges, inverse functions, combining functions, and now what we haven't talked about is inequalities. Now you might remember an inequality in C1, call 1 or whatever you want to. Oh wait, no. No, actually, sorry. We'll do inequalities in a minute. Actually, sorry. The thing we're going to do now in this part is we're going to talk about graphing the y equals f of x. So there's two types of parts. So it's not y equals fx, so it's y equals f the modulus of x. Now, to graph these, I need to explain what the modulus is. So the modulus, what is it? Okay, so generally, when you see a modulus, it won't say the word modulus, it'll look something like this. So the modulus of x take 3 equals 2. Now the key thing you need to know about the modulus, it's always positive. Doesn't matter if you have x is 1, take 3, no, minus 2. Well, it's negative. Well, modulus says, stuff you, we're going to make it positive, so it makes it positive 2. So it doesn't matter what you have. So if you had 5, take 3 equals 2, I might just say, yeah, sorry, positive. I'm going to let you live with that one. Puts 2 there. However, if you had, say, oh, well, what are you going to do when I put 1 there? The modulus will go, well, that's minus 2. We're going to change it to a 2. Why? I don't know. Do you really care? You don't. You just want to be able to pass your exam. So more to the point, I don't really know. So what could we have in that equation there? Now I am building up to graphing, but I'm just explaining the theory behind the modulus. So this is y equals mx plus c. So x could be, so that say we know a y coordinate there, this is what I'm trying to emulate to you. So x could be, so as we said, x could be 5, so because 5 take 3 is 2, or x could be 1, 1 take 3 is minus 2, and the modulus turns it into a positive. So that could be your 2x values for that one. So we've sort of touched on inequalities a little bit, that's why I was thinking along them lines, but the graphing is more important first. So what do we mean by graphing? Well, just drawing it on a graph. So I'm going to split the whiteboard in 2, literally, with my strong bare arms. And I'm going to draw a graph on the left-hand side and a graph on the right-hand side. Even though I said it the other way around is the way I'm drawing, just to confuse you. And I'm going to label one of these graphs. I want to get right. One is going to be f modulus of x plus 3, and one is going to be f modulus of x plus 3. So, yeah, right. Okay, so what does this actually mean? Okay, so what essentially we've got here is y equals x plus 3. Because fx is y equals. So what does the modulus of this mean? Okay, so what you can essentially think of this as is the modulus, remember, turns everything positive. So it can't be negative. So it can't, essentially, because fx equals y, it can't be negative y. So it always has to be, as the x-axis at y equals 0, it always has to be above the x-axis. See where I'm going with this? If you remember, our y equals 2x plus 3, that went negative. But how does the modulus over the whole equation make a difference? Actually, I'll change this to be y take 3, because this proves my point a little bit more. Does it? Yeah, sort of does. Okay, so does it? No, wait one sec. I haven't chosen a very good example there actually. So I tried to choose one of my own examples to prove my point, but it didn't work. Y equals 2x plus 4, that's better. So y equals 2x plus 4. That's our standard equation. Then what we put here is y equals bracket modulus 2x plus 4. And this is y equals brackets, modulus 2x plus 4, the whole thing. So how does this make a difference? Well, one, when it's just over, the modulus is just over the x, it can be negative because the number on the outside can make it negative. So that's why we've got that. So when it's just around the x, it is reflected from the right hand side into the left hand side. So that's the right way around, isn't it? However, when it's over the whole equation, the bottom half of the bottom half is sort of like a bounce off, so it's sort of a reflection essentially. So say we've got very good example here. So 2x plus 4 if it's over the whole equation, your normal y(x+4) would look something like that. Hit the point there, and then go back up. And essentially, what it tried to do, this y equals 2x+4, it would try to go down here, but obviously because the whole thing is modulus, it bounces back up. Essentially, it bounces off the x-axis. Whereas this same equation here, so we're still going down, but when we hit this point, because it's reflected from the left to the right to the left, it goes up like that. So you can see how the two graphs are very different, even though they're the same equation. You can see how having the modulus makes a difference. Damn it. So hopefully you understand that. So this can be negative. So on the left, where it's just over, the modulus is just over the x, it can be negative because of the number on the outside can make it negative. But as long as it's reflected from the right hand side into the left hand side, when the modulus is just over the x, it can be positive, because remember, y equals whatever that does, and if the modulus is negative, y is going to be positive, and if the modulus is positive, the y is going to be positive if the modulus is over the whole thing. But because the modulus is just over the x when it's just over the x, the outside number can make it negative, or any of the variations on that could make it negative. But the 2x is always positive, but because it's 2x, modulus 2x plus 4, the plus 4 bit obviously it could make it negative. So that's why that happens like that. You can work it out for yourself. I don't know if I could explain that much better. I'll just be treading on my own footsteps. But hopefully that's clear cut for you. Okay, so assuming you get that, we'll move on to the next part of it. Oh dear, I almost confused myself there. Sorry about that. So remember, if you've just got the modulus over the x, the rest of the equation could make it negative. So that means it's going to be reflected from the right hand side to the left hand side. Obviously, the whole thing is just reflected in the x-axis. So if you can imagine, well, it's not reflected; it doesn't go over the x-axis below it. So the modulus of the whole thing, when it hits the x-axis, it's going to bounce straight off. If it's going to go normally, say if an equation normally go through the x-axis like that, it hit the x-axis and bounce off. Essentially, if you could think of it like that. It's just going to be a reflection when it goes into the negative on the positive of the x-axis of the y. Yeah, not explaining it well there, not at all. Okay, so try again. When it's over the x, the modulus is just over the x. The outside part of it can make it negative, so reflects on the right hand side to the left hand side. However, when the modulus of the whole thing, because we know the modulus makes it positive, it's got to stay above the x-axis, and when it goes under, it reflects on top of the x-axis. Sounds a bit better in my mind. Pleased with that? Okay, so now we can go on to what I was trying to go on in the first place. I sort of touched on it a little bit with the modulus of x take 3 equals 2. So what I'm going to change the score. Instead of putting equals, I'm just going to put x take 3 is larger than 2. Now that is an inequality, larger than or equal to. So what we could say, remember the modulus always keeps it positive, change it to positive no matter what's inside the modulus, it'll just do that number positive if it's not already positive. So if you remember how we explained before, if it's 1, it's minus 2, but it changes it to 2 because it changes it to positive. However, if it's 5, then that's 2, and it's happy, bigger than 2. This is bigger than or, this is, oh sorry, wrong sign. Bigger than or equal to 2. So we had x equals 5 or x equals 1. Now we could continue to go the other way. So x takes 6, 6 takes 3. 3, that's larger than 2, so that satisfies this. Or if we go backwards from 1, so we could go up from 5 or backwards from 1. So x takes 0, 0, x equals 0, 0 take 3, minus 3, changes it to positive 3, that's larger than 2. So how can we summarise this into an inequality sentence? So we want x to be larger than or equal to 5, and we want x oh sorry, yeah, x to be larger or equal to 5 or less than and equal to 1. So that satisfies that inequality there. Obviously we could do this by a graphing method with y equals 2 and y equals x take 3, but hopefully you understand what I've just talked and how that's been explained. Is that a bit better? Yeah. So let's get a bit righty time. But what about, you know, it's always going to be that kind here. They'll give you something like this. X take 3. It's larger than, I'm going to keep the 2 bit, but it's going to be x take 2. Now what would you do then? Because both sides could be positive, couldn't they? So we can't do x take 3 is less than or equal to -1 because we don't know the right hand side of the equation is going to be equal to -1. There could be massive variations of other things, and you can't do logs because we're not dealing with powers, so that's out the equation. So what can you do? Well, give you a minute to think of that if you're from my class, but or if you've done this, or if you're just doing it as a revision. When we've got two modulus equations of each side of the inequality, we can't simply go x take 3, oh, well it's going to be positive. It's always going to be bigger than 2, so it could be less than 1 and bigger than 5. Can't do that because we don't know that's going to be equal to 2. So what do we do? Well, if you've not got it, we square both sides. So double brackets, x take 3 times x take 3 and x take 2 times x take 2. Don't forget to leave the correct sign there, so that's going to be x squared plus 9 take 6x, if that's right. It's bigger than, is less than or equal to x squared plus 4 take 4x. Now we've got two, oh that's going to work. Well, might do. I was hoping rather that turned to be a quadratic, but that's going to cancel each other out, which I'll explain how you do in the quadratic in a minute. So that's what we've got from this equation. Okay, so move all of this onto one side, so it's less than or equal to 0. So take away x squared from both sides, that gets us 0x squared, which I'm not going to need to write down. Take away 4x squared from 4x from both sides, that gets us, add 4x both sides, that gets us minus 2x. Take away 4, that gets us plus 5 on this side. So minus 2x plus 5 is less than or equal to 0. So what we can do then is move the 2x across, so add 2x. 5 is less than or equal to 2x, so simply simplify this. 5 over 2 is less than, x is greater than or equal to 5 over 2. So that's what you'd do. Now if it was a quadratic, so if this was 3x squared, so hopefully you've followed how we've done that. But I'm going to create a new, so hopefully, yeah, so we squared both sides, simplified it down, and then got to our answer there. That's quite simple. But what about if the x squareds didn't cancel? So, right, that was straight in the bin, it's had enough. So get rid of all of this, and then I'm going to assume that in the end we're left with a quadratic. So the quadratic could look like something like this. 3x squared plus 2x plus 1. And that is greater than or equal to 0. Then we factorise that, if that factorises. So this is not going to work, but just for purpose, this doesn't match that. Well, might not do. Might be a genius to do it. 2x plus 1. No, plus 1. That just doesn't equal the same thing, but assuming it does, because again it's quadratic off the top of my head, so I'm not sure it actually does factorise. So x would be either, so you've got here x is equal to negative a third, or x equal to negative 1, or equal to 0. Sorry, just missed something out there. And then you'd put, you'd put these values into that equation and see what happens when it's, because that's meant to be less than or equal to 0, and you could work it out from there. So basically trial and error. I think that's what you do at that point. If I'm wrong, just message me underneath, because it's not about me learning stuff as much about you learning stuff. I'm not going to give you all the easy stuff like you're watching one of them videos. It's not exam solutions, even though attempt to be. Okay, so hopefully we've got that. Right, so that's the functions there. I believe that's it. That's it for functions. So just a recap on what we did for functions. So to save you having to create your own mind map, I'll create it for you. So functions. Okay, so what did we do in functions? Well, we started off by saying the domain, because it's first in the alphabet, that's the x values. So the domain, so if you restrict the domain, you restrict the width of the graph. And if you restrict the range, you restrict the height of the graph. So that's the y values, or what you get from putting in an equation. So the resultant values. Exam Solutions calls it. Obviously, not watch their videos at all, by the way. And I wouldn't recommend it. I'm much better at this. So there your domain and range that we talked about your combining functions. That's putting one function into another, which is f of x into gx, so g of f of x essentially, and that's the same as polynomials. Which, if you're unsure what we mean by polynomials, you could just refer to my C1 or 2 or whatever it was in. Sounds like more of a C2 topic, I think. Talk about the inverse functions. And what we said about this, that was rearranging a function to get y as to get x as subject. So that's rearranging to get x as the subject. I'll move out of the way in a minute, don't worry. And on the subject of the subject, on the subject of inverse functions, we said the inverse function of a graph is reflected in the line y equals x. So that's what we said about inverse functions. We also said about inequalities. So should we have talked about inequalities? So I'm going to put the modulus down, but so basically for modulus and linear, all you do is your simple, what should we call it? Simple calculation. I just put simple calculation. So basically, modulus is always positive. Remember that simple modulus equation. I just put equation. However, for mod, I just put mod plus mod. Then we square both sides. And then I'm not going to necessarily write this down because I'm not sure if I have any room. And then we talked about graphing the two types of equations. So graphing f of x plus a and f of modulus of x plus a. And I'll split them up because the first one, if you remember, the a can turn these things negative, so that is reflected in the y-axis, and then where the whole equation is modulus, then that is reflected, that is above the x-axis, or reflected in the x-axis. So that's the whole thing for functions. That is the summary of functions. I'm not actually changed my mind during that. I'm not actually going to include any questions on functions. I'm just going to assume that was good enough for you, and if you need any extra help, or if I get any time in the future, I'll do some functions questions. But if it's urgent, then just let me know and I'll be able to put some questions on there. But otherwise, hope that's been enjoyable and you've been able to withstand the 40 minutes. Well done. We'll see you in the next video, which should be exponentials.